Distinguished ladies and gentlemen, in the last class we were discussing the nomenclature of alkanes. So in this video we continue from there. Now we have seen how alkanes can be named following the rules and regulations of naming. Now we are discussing the physical properties of alkane. Physical properties. One of the physical properties of alkane is they are insoluble in water. They are insoluble in water, but they are soluble in organic solvents. They are insoluble in water but soluble in organic solvents like benzene. Alkanes are soluble in benzene. They are soluble in substances like toluene. They are soluble in substances like xylene and so on. They are not soluble in water but they are soluble in organic solvents like benzene, toluene and xylene. Another physical property of benzene is they are colorless substances and odorless. So they are colorless and odorless substances. They do not have color, they do not have any smell, just like normal water. Another physical property is from the first member to the fourth member, they are all gases. From methane to butane, all of them are gases. From the fifth member to the 17th member, they are all liquids. They are all liquids. Then from 18 and above, 18th member and higher members are all solids. It means alkanes of lower molecular masses are gases, while alkanes of higher molecular masses tend to be liquids and solids. Higher molecular masses are liquids and solids. Lower molecular masses are gases. So it means the more we increase the molecular mass, the stronger the substances become, or the denser the substances become. Then another physical property is, we say the first member to the fourth member are gases. So these gaseous alkane are less dense than air. They are less denser than air. Meaning air is denser than these gaseous alkanes. They are less dense or less denser than air. So these are the important physical properties of alkanes. Now let's look at the chemical properties. Let's look at the chemical properties of alkane. Now, one of the chemical properties of alkane is they exhibit exothermic reaction. All alkanes exhibit exothermic reaction. Now, when we say exothermic reaction, any reaction that gives out heat is an exothermic reaction. Any reaction that produces heat and gives out the heat to the environment is an exothermic reaction. Meaning all the reactions of alkane always produce heat and that heat is given out of the system. So their reactions are exothermic, they give out heat. Now, One thing we need to know about exothermic reaction is that exothermic reaction have what is called negative enthalpy change. They have negative enthalpy change. Enthalpy change, that is heat change. They have negative heat change. How do they get negative heat change? It's because enthalpy change is given by heat of product minus heat of reactant. So if enthalpy change is heat of product minus heat of reactant, now the heat of product of alkanes or heat of product of reaction of alkane is always less than heat of the reactants. So if heat of product is less than heat of reactant and enthalpy change is heat of product minus heat of reactant, and this is less, this is higher. So a lesser number minus a higher number always gives you a negative value. This is why we have a negative enthalpy change. For instance, if I have my HP as 2, heat of product, and my heat of reactant, let's say, is 5. Now if I say 2 minus 5, my answer is minus 3. This is why I will have a negative enthalpy change, because my final answer is negative. And the difference between HP and HR is my enthalpy change. So I will have a negative value. So the delta H or enthalpy change of exothermic reaction is always a negative enthalpy. So all alkanes exhibit exothermic reaction. They give out heat in their reaction. Another property of alkanes, chemical property, is they undergo substitution reaction. They undergo substitution reaction. Now, we made mention that alkanes are saturated compounds. And when we say compound saturated, it means it has a complete number of hydrogens it will have. So it is not lacking any hydrogen. So if alkane is complete, is saturated, and it wants to undergo a reaction, meaning you cannot add any other element to alkane. For you to add an element, you must remove something from it. Meaning you must remove a hydrogen before you can add another element. So that removal of hydrogen to put another element is what is called substitution reaction. So alkanes undergo substitution reaction because they are saturated. So you cannot add, you can only interchange. That is substitution. For instance, if I have CH4, then I have Cl2. I'll have CH3, Cl plus HCl gas. Now, my alkane here is methane, CH4, 1 carbon, 4 hydrogen. Now, if I want to add an element to it, let's say I want to add chlorine. You see, I cannot add chlorine until I remove one of the hydrogens. Now, if I remove one of the hydrogens, I have only 3 hydrogens left. Now that chlorine can replace the position of the hydrogen that has gone. Then that hydrogen that goes out now reacts with the other chlorine to form hydrogen chloride gas. So this is a typical example of substitution reaction. So in substitution reaction, for you to add an element to a substance, you must first remove one element. So if I remove hydrogen, I put my chlorine. Now I have a compound with chlorine and the hydrogen is gone out. This is substitution reaction. So they always undergo substitution reaction because they are saturated. Now another chemical property of alkane is what is called combustion. Number 3, alkanes undergo combustion, or you call it oxidation. So alkanes undergo combustion or oxidation. Now the formula for combustion of alkane is CXHY plus X plus Y over 4 oxygen to give XCO2 plus Y over 2 H2O. So when alkane undergoes a complete combustion, this is the general formula to represent that. For instance, if my alkane is let's say C3H8. Now if C3H8 is to undergo a complete combustion, my X, based on the formula, my X is 3 and my Y is 8, meaning anywhere I see X in the formula I put 3, any place I see Y in my formula I put 8, because my CXHY is C3H8. So I'll have 3 plus 8 over 4 O2 to give 3 CO2 to give 8 over 2 H2O. So this gives me C3H8 plus 8 over 4 is 2. 2 plus 3 is 5. I have 5O2 to give me 3 CO2 plus 8 over 2 is 4 H2O. So if this compound, which is propane, if 1 mole of propane undergoes a complete combustion, it requires 5 moles of oxygen to produce 3 moles of carbon dioxide and 4 moles of water. So this is 1:5:3:4. So if propane undergoes a complete 1 mole of propane undergoes a complete combustion, it will produce 5. It will need or require 5 moles of oxygen to produce 3 moles of carbon dioxide and 4 moles of water. So this is complete combustion or complete oxidation of alkane, particularly propane. You can change this compound with a different compound. You can arrive at entirely different answers. So another property of alkane apart from combustion is hybridization. Number 4, hybridization. Now, hybridization is similar to bond formation. This topic is talking about how the bonding of alkane is formed. You see, hybridization is the combination of electrons from 2 different atoms in the same orbital in order to form a bond. Combination of electrons from 2 different atoms in the same orbital to form a bond between the atoms. So the hybridization of alkane is always sp3. So the question is, how do we arrive at sp3? All alkanes reaction produces hybridization of sp3, meaning the bonding in alkane is always sp3 hybridization. How do we produce that? Let's give an example with formation of methane. When carbon reacts with 2 molecules of hydrogen, we have methane. 1 carbon with 2 molecules of hydrogen or 4 atoms of hydrogen will produce methane. Now, if you look at the structure of methane, this central atom is carbon. Central atom is carbon. And the atomic number of carbon is 6. Meaning carbon is 1s2, 2s2 and 2p6. This is the electronic configuration of the central atom, which is carbon. Now, this electronic configuration is what is called ground state electronic configuration. Ground state electronic configuration. Now, carbon atom cannot undergo a chemical reaction or a bonding while in this state. So for carbon to react with this hydrogen, it must change this ground state electronic configuration to what is called excitement state electronic configuration. Now, if I draw the magnetic box of this, I'll have this. This is 1s, 2s, and 2p. This is 2 electrons, and 2p has only 2, so I put 1, 1. This is still representing the ground state electronic configuration. Now, for this carbon to react with the hydrogen atoms, it must change from ground state to what is called excitement state. Now, for it to convert to excitement state, this electron in 2s will migrate to this box, because this first box is px. the second box is Py, and the third box is Pz. So one electron from 2s we have to migrate to the Pz orbital. So this migration of electron from a lower energy level to a higher energy level is what is called excitation. We call this movement excitation. Now immediately when carbon undergoes excitation, the electron moves in position. So the new electronic configuration is what is called excitement state electronic configuration. So what I produce now is I have 1s2, I have now 2s1 and 2p3. Why? Because the 2s was having 2 electrons. And now one of these electrons from 2s has migrated to pz, meaning 2s is reduced with 1 electron, p has been added 1 electron. So I have 1s2, 2s1, 2p3. So the new magnetic presentation becomes something like this. I have 2 electrons here. This is 1, 1, 1, 1. So now this one is called excitement state electronic configuration. Excitement state electronic configuration. Okay, now we say carbon cannot undergo a bonding in this state, but it can undergo a bonding in this state. So let's see how the bonding takes place there. Now after excitation, what I have here for carbon is something like this. We say this is my Px, Py and Pz. This is my 1s, 2s, this is my 2p. So here I have 2 electrons, here I have 1 now, 1, 1, 1. Initially I had 2 here. So one of the 2 has migrated to Pz, so that we have 1, 1 electrons throughout. Now if you look at this, we have 4 atoms of hydrogen. Now because I have 4 atoms of hydrogen, and each hydrogen atom has 1 electron, so one of the hydrogen here will combine with this to form a bond. Another hydrogen will combine with this. Another hydrogen combines with this, and the other hydrogen combines with this, because each hydrogen has 1 electron. And we have 4 boxes that require 1, 1 electron. Now, you can see in each of these boxes, 1, 2, 3, 4. We have, in each of these boxes, we have combination of electrons from different atoms. In this box, we have the black electron from the carbon, the red electron from hydrogen. 1 electron from carbon, 1 from hydrogen, 1 from carbon throughout the combination. Now, the combination of electrons from different atoms in the same orbital to form a bond is what is called hybridization. Combination of electrons from different atoms in the same orbital to form a bond is what is called hybridization. Now this new formula or this new compound is our CH4. Why? Because now we have combination of carbon and 4 hydrogen. Now if you look at this very well, we have hybridization in 4 boxes. 1, 2, 3, 4. In 4 boxes. We have hybridization in S, in 2s, we have hybridization in px, we have hybridization in py, and we have hybridization in pz. So I have 1s, 3p. This is why we have sp3 hybridization for alkane. So this is how it is arrived at. So another chemical property of alkane is the functional group. The functional group of alkane is hydrogen. Number 5. The functional group of alkane is hydrogen. Now, every compound has a functional group. Every organic compound has a functional group. So the functional group of alkanes is hydrogen. Now, when we say a functional group is an atom or group of atoms that determine the reactivity of a compound. An atom or group of atoms that determines the chemical properties of a compound is what is called functional group. So what determines the reaction? What determines the property, chemical property of alkane is hydrogen. That is why hydrogen is the functional group of alkanes. So this term functional group, it is either call it functional group, or you call it specific group, or you call it determinant group, or you call it reagent group. So you can call it functional group, specific group, determinant group, reagent group, or you can call it reactive group. Reactive group. All these mean the same thing. So the specific group, determinant, reagent, reactive group of alkane is hydrogen. So these are the chemical properties we need to know of alkanes. We have combustion, we have substitution reaction, we have exothermic reaction, we have hybridization, and we have the functional group. Okay, now let's look at the preparation of alkanes. How do we prepare alkanes? Preparation. How do we prepare alkanes? Now, one of the preparation of alkanes is by hydrogenation. Hydrogenation of alkanes and alkynes. By hydrogenation of alkenes and alkynes. When you hydrogenate these two compounds, you produce alkane. For instance, if I have C2H4, this is an alkene. Then I add 2 hydrogen to it. This addition of hydrogen to this compound is what is called hydrogenation. So this will give me C2H6. Now you see I produce an alkane from alkene. If I have C2H2, this one is an alkyne. So when I add 2H2 to this, it becomes C2H6. You see I'm still forming alkane. So addition of 2 hydrogen to alkene produces alkane. Addition of 4 hydrogens to alkyne produces alkane. So hydrogenation of these 2 compounds will produce alkane. That is one preparation method. Another method of preparation is when you react sodium alkanoate. When you react reaction between sodium alkanoate. Sodium alkanoate also called ester salts. So when you react this with soda lime is sodium hydroxide. Now when you do this reaction, you produce an alkane. You produce alkane. Very good example is if I have CH3, CO or sodium, and react this with sodium hydroxide. Now this is sodium ethanoate, which is a sodium alkanoate or an ester salt, and I react this with soda lime, that is sodium hydroxide. What I'll produce is I'll have sodium trioxocarbonate plus methane. Yes, this is what I'll produce. This CH3 will react with H to give me CH4, which is my methane. Then this CO plus this O will give me CO3, which is this. Then this sodium with this sodium will give me sodium, 2 sodium atoms. So if you react ester salts, that is sodium alkanoate, with soda lime, you always produce an alkane. Like in this example, we have produced methane. So you can do other examples with similar compounds to produce other alkane. Let me use one other example. If I have C2H5COO, sodium, this is sodium propanoate. Sodium propanoate plus soda lime. Sodium hydroxide, I will have sodium carbonate plus C2H6. So we can produce alkane using this preparation method. Now, after knowing the preparation of alkane, let's look at the uses. And with that, we are through with alkanes. Now, we have two important uses of alkane. One of them is they are used for surgical operation. We're talking about uses of alkane. That is for surgical operations. How? Now we have a derivative of alkane that is called trichloromethane. Trichloromethane is derived from methane. When you have 3 chlorine attached to the methane, we have trichloromethane. So this chemical is used as an anesthetic reagent. Anesthetic reagent is what is used in surgical operation to make a patient sleep. So before you start your operation, you have to make the patient sleep. So one of the chemicals you apply to the system of the patient is trichloromethane. It is an anesthetic reagent. It makes the patient to sleep until the operation is done. So this is one use of alkane. The second use of alkane is that they are used as fuel. Alkanes function as fuel. Very good example is octane gas. Octane solid is a liquid, but a volatile liquid, gaseous liquid. So octane, which is C8H18, is a very good constituent of fuel. It is used as fuel. It is used in gas lamp. It is used in some lighters and other gas cooking equipment. Gas cookers. So we say alkanes are used as fuel. A very good example is octane gas, which is a volatile gas. Is a liquid when you compress it, but when you expose it, it becomes a gas because it is volatile. So it is used as gas lamp, lighter. It is used in gas cookers. So these are the two important uses of alkanes. So at this point, we are through with alkanes. So in our next video, we discuss alkene, which is the second aliphatic hydrocarbons.